Hello and welcome to Azure's Live Mert to the Future. Today we are going to talk about Azure's default service. I think it's not wrong to say it's a default service for application insights because all of the Azure services has application insights integration. And today we are going to integrate JVM based applications for application insights. And I have a very, very special guest today, and Pamir Erdem. Pamir, welcome.
Thank you very much. And do you want me to start right now directly?
No, I know you don't like introductions, but can you please introduce yourself shortly?
Okay. I'm Pamir Dasit, so I'm working especially on JVM-based application and JVM-based container application, and for their performance tuning and their troubleshooting. And today, first of all, we will going to deep dive into how to troubleshoot container-based JVM applications, how we are approaching the problems when there's a problem in the container space. And after that, there's a new feature that is Azure has provided for JVM applications. There's a application insights integration with the JVM application. Was 5 minutes or 10 minutes. We are going to make a demo application for application insights for JVM application. And if you are available the next week or 2 weeks later, we're gonna deep dive into the application insights for .NET and JVM applications again, if you want, by the way. But today we'll be focusing on how to troubleshoot, especially JVM application inside the container. And after that, we will just integrate the application insights for that.
Okay, great. So let's start.
Okay, so I'm gonna close first of all my camera. Sorry for that. So the thing is, for example, to be honest, it is my demo application which has some troubleshooting patterns. For example, let's talk about what are the troubleshooting patterns. For example, just a second. Let me open the notepad, and basically you are seeing my best presentation tool ever. First of all, as you know, there are kind of problems we are facing in the production system. First one is our users came to us say that our system is slow or the CPU utilization is too low. For example, 3% or 2%, and no any CPU utilization on the VM side or the container side. So the first pattern is low CPU hang situation. The other one is, for example, if in the development phase, let's say that we made a mistake and then we made high CPU utilization, which we really don't expect it. So the second pattern is high CPU hang. The other one is, first of all, for example, we make a cache system for our application, and after that we see that the garbage collection will not delete is not deleting the old objects, and there's a memory leak. So the third one is memory leak pattern. So how we're going to approach memory leaks in the JVM-based application, how we're going to make, for example, a dump, and after that, how we're going to analyze the memory dump of the application. And we have, for example, thread leaks for that. Thread leaks. What are thread leaks? The thing is, for example, we had a stopwatch controller in our JVM application, and after that, for example, we created threads, and after that, again, we create a thread, and after that, we again create a thread, and we don't delete the thread, so there's a thread leak, like memory leak. So when you dump the memory, you're going to see that there's some kind of threads in the memory, and even if the threads are in the memory, but they're not executing any sort of source code. And we have, for example, another case which is single thread high memory usage. Especially this is for example, we have 5 or 6 or 10 or 60 threads in the JVM application, and every thread is responsible for getting some sort of data from the database side. And let's think about that. We forgot to set the where clause of our SQL statement, and after that we will retrieve a whole sort of data from the database. So the thing is, when we dump the memory, we will see that one thread is consuming more memory of the JVM memory usage. So another one is, I will not mention is, crashes. So the thing is, for example, when you develop some sort of application, and after that there's an exception and the application closes. What is the last state of the application? Which exception is occurred? How are we gonna dump it? How are we gonna learn that? Which thread, which responsible source code is executed the execution, and why our application is crashed? So we will make, for example, crash analysis. And so again, infinite wait, which is again related with low CPU hang. The thing is, infinite wait and low CPU hang is very similar to each other, and infinite wait is so some function or a function holds the synchronization object, and another thread wants to get the synchronization object to execute its code. So if the first thread is not releasing the synchronization object, the other thread will wait on the synchronization object. So this is for basically a Docker file. It is very basically a Docker. We will generate a Docker image for our application, and this is for my application, and we will set infinite loop, infinite wait, memory leak, single thread. We will set the parameter. We will pass the argument to our main class, and after that, if there's a non-finalized or crash on error or class loader leak, we generate our leak or problem to our application. We will generate the problem for our future analysis. And so basically, we will generate a jar file, and after that, we will make a Docker file for that, and after that, we will execute it. So we will get the memory dump, or we will get the thread dump. So I said that two things. One is thread dump. Let me make it a little bit bigger, and memory dump, or thread dump, also known as call stack dump analysis. So basically, what are these? This is that one. So what are these? If the application is related with threads, and for example, when do we dump the memory? When do we dump the stacks? Or in terms of .NET applications, mini dumps. Why thread dumps and memory dumps are so essential for us to analyze the problem. The thing is, for call stack is related with CPU, or not CPU, let's say that it's related with the hang analysis. So we see that the CPU utilization is very low, where the CPU utilization is too high. Dump the call stack, and you will generate a thread dump for that and make an analysis for your application. And for the cache analysis or memory leak applications, because if there's a memory leak, or we mentioned that there will be a high memory usage on a single thread, so dump the memory. Or we want to understand that what are the objects that is in the memory for SQL Server. So we will need some sort of information from the memory analysis, then we should dump the memory. So basically, we will have two methods to analyze the problem. First one is callstack, which is related with the CPU or I/O bound operations. The second one is for memory analysis, we should dump the memory. I mean the JVM memory. So let's start with, first of all, how we should dump the memory. JStack is first tool, and the kill command for Linux applications is the second command that we can make for thread analysis. So let's start with infinite loop. So I don't know the source code. I mean, I know the source code, but you don't know the source code. And let's see that how we are troubleshooting the application. But first of all, what we are going to do is, this is my JVM dump use cases folder, and I have the exact same source code in here. So what I'm going to do is docker build -t JVM / use
Pamir, can you please increase the font size a little bit?
Yeah, it's okay right now. I think so. Please say yes.
Yeah.
Okay, let's set a version, and I think it's okay. So let's build our application. So it seems to be perfect. So docker image, let's execute docker image, JVM cases. So first of all, what we are going to execute is our infinite loop application. Where is our Docker file? It should be in here. So how I'm passing the arguments? I'm passing the arguments as environment variables. So let's execute this Docker image. So docker run -it, and let's -e problem. Let's set the problem for that. Infinite loop and -e JVM. Oh, I'm passing the argument JVM arcs. Yeah, that should be okay. So JVM cases, set the version. So let's execute this one and see that it should say something very important for me. Just a second. I think it should work. It should be working. Okay. Yes, -f. I should see some sort of notification in here. I didn't understand why it's not working. An update is available. So from the first moment, I'm shocked that Docker is not working. Okay, infinite. No, infinite loop is expecting infinite wait. Let's make it infinite wait. Okay, perfect. So I generated some example problem. Infinite loop is another problem. Infinite wait is another problem. Let's first of all start with the infinite wait. So what I'm doing is I pass the infinite wait to my application, and I don't know the source code exactly. Let's assume that we don't know the source code. We don't know anything about the application, but somebody told us that there's a problem in our system. And what we have done is, first of all, we execute this command htop and see that the CPU utilization is too low. And we are trying to understand that what is the problem for our application. So let me stop it. And the CPU is too low, or there's a slow response times, high response times in our application. What we are going to do is, first of all, in our container, we will execute the ps to understand that, to get the container ID of that. So what I'm going to do is I'm going to make a sidecar application. So I don't have right now, just a second. I should create one sidecar for that. Just a second. Let's try the code. Okay, I'm done. So let me open my notepad again. So the thing is, what I need is run. What I'm going to run is -rm-it-net. So basically, I'm saying that I want to share the namespace of the container network namespace. So network namespace will be shared with container that, and what is the container ID? This is the container ID. I'm sharing the network namespace. So this time I will share a process namespace of the container. You know that there are 6 namespaces for containers. So one is for process namespace, network namespace, user namespace, IPC namespace, UTS namespace. So basically, right now I need 2 namespaces. One is the network, the other one is the PID namespace to retrieve some process information from the other container. So basically what I'm doing is right now I'm making a sidecar for the other container, the main application. So PID container should be this ID1, and let's -v tmp. I will map my tmp folder with the other container from the host machine. --privilege. Why I need privileged containers while I'm debugging? Because I need to stop the CPU register while you're dumping the memory. Right now, I will not dump the memory. I will just create a call stack of the other container. I don't need right now, but in the future, for the memory analysis, I need this one because I need PC trace capability. So instead of giving PC trace capability directly, I'm saying that privileged. So don't use it in production. Privileged. So the other one is, what I need is JAttach container. JAttach image. So basically, I'm setting the image name for that. So right now, I will execute bsh. So download JAttach image, map the host of the temp container to the temp folder, share the container namespace, process ID namespace for the other container, share the network namespace with the other container, from the main container. So basically I copied it and pasted it. So let's see it. Okay, it's not working. .ps fe is everything fine. -n that's what I am missing. So instead of that, it should be --net. Okay. So when I execute ps-f, I get JVM and infinite wait application. So I see that the application is running. So because I shared the namespace of the other containers process namespace, I have a chance to see other containers process ID. So what I'm going to do is right now is, so basically they told me that, the users told me that there's a slow response times, or when I execute the web page, no response is coming. So I should dump the memory, because from the analysis of the web page, users taught me that the system is very slow, it's sluggish. So what I'm going to do is, first of all, first command to dump the call stack, kill -3, and what is the process ID? It's 7. What I'm executing is kill -3, the process ID of the process. So this time, when you execute this command, the normal output of the container, the main application, will just print whole call stack to the console, to the terminal. So what I understand as, let me analyze it, but if there's a slow application, you should do it within 5 seconds 3 times, or within 10 seconds, just kill -3, 7, kill -3, 7, 3 seconds or 4 seconds consequently. So when I execute this one, I get the memory usage of our application, and I see the threads call stacks. So what I'm doing is right now, I will read the call stack from bottom to up, okay? So because call stack is a stack, so let me tell you that, for example, if A method executes B method, so B method executes C method, from the call stack, I will see something like that. A executes B, B executes C. If I see in the call stack, so I understand that C has some problems in tree dump analysis, because I executed kill -3 for 3 times or 4 times. In every call stack, if I see C at the top of the threads, so basically I will suspect that C or B is and has a problem. So what I'm doing is, first of all, this is the first thread, it's the main thread. So what I'm doing is main executes infinite wait run method, and it's join. So it creates a thread, infinite wait run internal creates a thread, and it tries to join. So it's waiting on this object. So basically I find it. So the second thread is not this one. There is a second thread, that one, super cool. We find the second thread, and it creates a second thread, and we are basically seeing that it is blocked. It is blocked off on object. So we get the ID of the synchronization object, so this one, and the infinite wait in here. So basically we found the problem. One thread is on the join state, so it's waiting. The other thread is on the blocked. So if you have too many blocks, or if you have, for example, if your all threads are waiting on the same object, so you will be suspecting that there's a synchronization issue. For example, from the connection pools, connection pool mechanism is exactly the same way. If you try to open too many connections at the same time, when you dump the call stack, you will see that all threads where every thread trying to open a connection, we're waiting on a synchronization object, and it's trying to open a connection. So the second method is, so we find it, so let's prove that it's exactly the same way. So what we have seen is, on the main method, let me open this one first of all. Thread join, infinite wait dump cases, run internal, infinite wait, that one. From the infinite wait, there's an object, run internal, there's an object. So basically, it is not releasing the synchronization object, it's waits on an object. So the other one is where it is, infinite wait, run. It's blocked. Again, we see that all threads are blocked on the same object. So basically, we found our problem for the infinite wait. But the second method is, for example, if you cannot get any output from the kill-3, we should find we should retrieve the call stack, which is JStack. That's why when you're dumping the memory, or if you need some sort of call stack analysis, this image will be your your guide. So we need J attached for that, to dump the memory, or let's say that retrieve the memory, or if you want to dump the memory, J attach. So what is the ID of our process? It's 7. So, or let's execute help first, and CMD, super cool. It doesn't say anything, so J attach 7 because our process ID is 7. And what I'm going to do is thread dump. So basically, I successfully retrieved the call stack. So what I'm going to do is right now thread dump, first of all, TMP and threads.dmp, waited for 3 seconds, waited for 3 seconds, and right now I have a chance to analyze the 3 call stacks. So I can exit this container, so my container will be vanished and it will be removed, so my sidecar is totally killed. So what is the second thing that I can do from a GUI? Yes, okay, from terminal. Okay, so it was easy. What about opening it from, for example, dev tools? Here's my TDA, thread dump analysis. I don't have, so let me download it. Thread dump analyzer, JVM. Let's download it. Smart thread, no, I don't want to. TDA, I want that one. I think it should be. Downloads. Where is the release page for that? Got TDA. When I need something, I always delete it. I don't know why. TDA, but TDA. Okay, that's good. So let me download it then. Got. Somebody's messaging me. So let's open it. It's on. Okay, we downloaded TDA S LS TDA box. I'm lucky, I can open it. Okay, I open it. So another thing is we shouldn't forget copy it to the Windows CP or move our threads DMP to mmtc dev tools data. Okay, operation. I successfully copied my threads to my Windows machine. So let me first of all. I will open it because I have some special message. Tools, another window, tools data, and just stop. Yeah, that one. I just opened the thread dumps. So there are 3 thread dumps in here. So first of all, let's open it. Okay. Threads in here. Yeah, that one. So right now it seems perfect. It's small, I know that. Let me open again one tool, zoom it. So the thing is, right now I have a visual tool to see that all threads. So the thing is, first of all, thread 0 is blocked on an object, and the other one is waiting on an object. So this thread is blocked by this threads. Threads is locking main. So I understand that by looking at the call stack right now in here. Application main executing infinite wait, and then it's on the run method, and run executes run internal, and we are waiting on an object. So it blocks all the other threads. So basically they are exactly the same pattern happens in here. So we are 100% sure that there's a lock issue in our application. First approach is that, okay, so if you have a blocked issue, thread synchronization issue, CPU utilization issues, then first thing you should do is dump the threads 3 seconds intervally. So the second pattern is that we talk about, let me open my notepad again, high CPU hang issue. Let me open our source code again and see that where is the high CPU hang problem. Thread leak, single threads, high memory usage, no. I need a CPU issue, infinite loop, that one, perfect. Infinite loop is a CPU problem. So, I mean, if you're not going to, for example, let's close the source code. But first of all, I need the argument for that infinite loop. Yeah, exactly. So the first thing is, for example, if you see that, let's execute this comment in here. And for example, you see that all the time, one CPU is consuming too much CPU, or all threads are consuming too much memory. Oh, sorry, all CPUs are in 100% execution time, not like this one. So the question is, what is consuming my CPU? Who is executed by our CPU? Why my code is executed in that behavior? How can I analyze it before going to application insights or some APMs? How am I going to troubleshoot it? So the thing is, first of all, let's stop this container again. This time I will execute with, instead of infinite wait, I close it. Good. Okay, this time I close it. Infinite wait. So instead of that, infinite loop. So I executed infinite loop and see that my all CPU utilization is not too high, but it's high. So the question is, which code right now is executing on our CPUs? Who is consuming? Is there a problem in our code, or how can I find it? Again, we will execute docker ps command again, so we will get the container ID of our image. So what we are going to do, instead of that, again, we will replace these container IDs with the current process IDs, sorry, container IDs. And right now I don't need it, but I will put it for my future analysis. Copy and paste for our copy and paste operations. So let's execute it again. Again, ps-f. I see that it's okay. So what I'm going to this time is execute process ID has 8. So what I'm going to do is kill-3 8, kill-3 8, kill-3 8. 3 times, 3 seconds. I mean, this is the rule. 3 times, 3 times to understand the problem. So again, to the output, it is, I mean, executed. So the thing is, okay, cool. Busy hiatus. What I'm doing right now. So there's an infinite loop in here. Got it. Main executes run, run executes run internal, and this thread. So basically, I can say that threads are created, and again, what we are going to do is from bottom to up, we will read this code. This thread is executing dump cases utils busy IO utils .run methods, and this method executed web page loader methods, load method, web page loaders load methods. Web page loader methods is executed by executed load method, and it executes org apache http blah blah client.execute methods. So this time I understand that from the call stack, this thread is not yet connected to the endpoints. It's socket.connect is executed, not is waiting on something. It's socket.connect. So the thing is socket.connect is important. So it tries to connect to the endpoint. Again, I see that socket.connect, socket connect. Again, the same pattern in here. So again, the same pattern happens in here, socket connect. Again, socket.connect. Again, socket.connect. Again, socket.connect. Again, socket.connect. Again, socket.connect. So basically, I can understand that this web page loader has an issue. It does not have a CPU or, let's say, that memory utilized code. It just creates threads, and after that, it tries to connect to the endpoint all the time. There's no wait time. I didn't see any retrieving. It tries to connect to the endpoint. So that's why I see at the bottom this one or this one, because CPUs are okay, but it's infinite wait, infinite loop. Sorry. I'm trying to understand these right now, the patterns, because it needs SSL for that. SSL is a CPU bound operation, and there's no IO bound operation in here. They're all, let's say that. I mean, if I see that it's on trying to IO wait or it's trying to retrieve a byte from the network, yes, I can say that is IO bound operation, but not right now, it's CPU bound operation. So the thing is, how am I going to analyze it? Again, I have a chance to dump the memory with the J stack. Sorry, call stack with the J attach comment, and after that I will retrieve, and then I will open it from, let's say that, from TDA dump analyzer tool. So let's open the code and say that yes, everything is exactly the same. It's happened on I told just a second ago. So the thing is, let me open the web page loader. So let me web page loader busy IO utils. First source code is this one, busy IO utils. What is that? Busy IO utils. Busy IO utils. Where is it coming from? Let me open it. Busy IO utils. Utils. So there should be a utils comment here. That one. So what it's doing in here, it creates 20 threads in here, tries to download the page all the time. If there's a problem, it prints the error to the output, the default output. So let's see that 20 threads are created. One is in here. No, one is in here. Seconds, thirds. Instead of that, I would directly go up and see that 16, I should be 19. It's a zero-based execution. So basically, yes, exactly 20 threads are created. So the other one is, the other issue is, let's make a memory operation in here. Host by, okay. Let's stop it. Let's see that a memory issue and how we are going to dump the memory, and after that, how we are going to analyze the memory. So let's first of all, memory leak. Okay, so let me open my main class. I can see it. Yeah, that one, to create memory leak. Yeah, that one. So the thing is, right now, instead of that infinite loop, I will execute memory leak for that. So again, .ps time. Where is my of that in here? This time for dump analysis, I need privileged container because I need a sysptrace capability for dumping the memory. Yeah, that one. Okay, yes, the chef. this time 7 J attach 7. I hope I can find it. No. Dump. I should be sure that it's memory dump or something like that. Just a second, I should look at it because I cannot remember all the time. So J attach, what was the command for that? Yeah, heap dump instead of memory dump. Heap dump. So we're just going to dump it. TMP memory leak 1 at hprof. H, that one. Okay. Heap dump. Why? It should be working. Heap dump. Heap dump. Doesn't it change it? Operation heap dump not recognized. J attach. Okay, where is the comment? J attach heap dump. It should be in here. I really don't understand it. Heap dump, heap dump, heap dump. Search. Search together. J attach heap dump. Yeah, that one. Or I couldn't remember the heap dump. Dump heap. Sorry. Dump heap. Okay, super cool. P, can I see it? No. But what I can do is I can close it. Yes. Close it 2 minutes ago. So let me open TMP ls. Oh, too many costs in here. Docker. What I'm going to do is this time, because I dump it from the main container, the heap dump resides in the main container volume. So what I'm going to do is this time I will copy the heap dump from the container, the killed container, because this time I should copy it from the past ID of container. So this one, where did I dump it? TMP dash memory. What was the command I executed this? I couldn't remember it again. That one. This time. CF plus data. Okay. I copied it to my local machine. So the tool that I'm going to use is cdef memory analyzer tool, which is for memory analysis, not for thread analysis, but you can use for thread analysis tools. And not for that. Let me open memory analyzer tool. You can download it from, again, Eclipse web page. Download the latest version and open your hprof, memory dumps from memory analyzer tool, so we can analyze it, your memory dumps. So let's wait for 1 minute to open our memory analyzer tool, and let's analyze our memory. Again, let me open it. Open heap dump. Yeah, that one. I copy it to here. And see that leak suspects. Yeah, perfect. So let's close it. let's close this one. First of all, what I'm going to do is there anything related to here? JDK, it uses here. Okay, it creates some sort of, I mean, this thread is doing some sort of HTTP connections. It's trying to read something from it. So I will try to understand what is the memory usage of that, and what is the memory, what are the objects that is or on the memory, and I will try to understand that who is holding what. So the thing is, there are too many byte objects in here, and I will try to understand that who is this time. Let's go with this one. List of all objects. The objects that is byte array is referenced. This with incoming references, who is holding byte array. So I will this one. So basically it says that client async thread pool size is holding this one, and it's value linked list map and annotations on reflects some sort of unrelated stuff. Did I open the correct dump? I could let me open one more time. Dumps. No, that one. Yeah. It should be the time. Sorry. It should be memory. Just background. This one. Let's go with this one. Again, we will do this stuff, who is holding what objects. So if there's a link in here, so I can understand that, I mean, who is holding what, and then if there's a memory leak, I can see it. I mean, basically this one, I will share more details in the next session. So basically, this is the idea for troubleshooting application. If there's a CPU1 operation in here, yes, sir. You interrupted me. Yes, listen to you. Mert?
No.
Okay, you open it. So let's continue. So these are the techniques that we are using for troubleshooting JVM applications inside the container, outside the container, in a WebLogic application, or IBM WebSphere, or whatever it is. So if there's a problem, this is the approach we are doing it. So the third option is, what is the advantage of, for example, connecting to application insights? If you are in this session, most probably you are using application insights for that. So the thing is, what I'm trying to achieve is, this time I will try to, I mean, ls pwd tmp folder. Let me dev projects ls cd, this time string pet clinic ls. So I have just a simple application, Spring Pet Clinic. You can download it from GitHub. And this application insight jar is important, because when you if you want to make this some sort of analysis like I did in the previous minutes, but on the other side, we need this application insight agent for our JVM application. So by this agent, we can understand that memory leaks. We can understand that call stack analysis. We can understand that why our application is slow. We can understand the queries that is executed on the application. So how am I going to start this? First of all, what I need is, I will go to Azure portal, and where's my portal? Not this one. Yeah, that one. So what I need is, I will create a web application insights from the UI or wherever it is. But the thing is, this connection string is very important. While I'm executing, running my application, I need this connection string, okay? So I copied the connection string in here. So let's see that. Let's do another application. Java, not this one. Let me first of all, we don't have much more time, so insights. In our tabs, I will open it. Insights. I think this time. Okay, super cool. So basically what I'm going to do is, yeah, that one. So let's investigate. Let's tell this what the comment is. So basically what I'm doing is this time I'm saying that Java, I'm saying that Java agent, this Java application insights agent. Open the Java application with this agent. So by this way, I can make a method instrumentation. If there's a problem in here, I will get the JVM insights from application insights agent. This is important. If you don't set the Java agent, we don't have a chance to monitor your application or make a profile your application, or we don't have a chance to get to monitor your application. The second comment is, the second parameter is the jar file, you know that, so to spin up a container. So I'm saying that this time application insights string from the environment variable, we are passing the application insights connection string to the Java application. So let's execute this comment and see that everything seems okay, and we connected this application to application insights. What has happened? Application insights, Java XJAR. I copied too many comments. Unable to access jar file. Okay, it's indeed in here. So let me go to Spring Pet Clinic. This time it will work. This is the environment variable, and this is the Java code. Not this one. I should delete it because not the ID. ID is not important. I should copy this whole URL stuff. So let's execute our application. Yeah. If there's any problem, it will execute. It will say that. It will tell you that the application insights is not working correctly. So let's make an example for that before making a successful execution. For connection string, workspace. Let's do this one. Instead of that, let's execute by this way. No, it worked. Interesting. If there's a problem in your application insight connection string, you will see an error that we are prompting to the terminal. So I executed my Java application with the application insights agent. So the thing is that we open the web page to make some sort of web page activities. So this is Spring Web Application. I opened it. Let me last name Erdem. I couldn't find anything. These are the stuffs in here. Let me again go to the home page. Again, find owner, add owner. It doesn't matter right now. Let me add Lola. Edit it. So the thing is, let's do some analysis in here. So when you are executing your applications to here, last 30 minutes, it will come in, let's say that in 10 minutes or 5 minutes intervally. So let's apply for 20 hours. And I see that I have one instance in here. So if I have multiple instances like 3 or 4 or 5 or 7, I will see that 7 instances within the last 20 hours. So there's some sort of SQL executions in here. And with logs, I have a chance to see that my logs, the select statements that is executed for my application. I have a chance to investigate the SQL comments, why they are slow or why they are blocked on some queries. So the thing is, for example, again, let me go back to for 12 hours before. So I have some requests in here. I have a chance to see failed requests, server response times in here. So I can make some good analysis. If, for example, I see that 2 seconds, 3 seconds for the response time, so I definitely say that there's a problem here. So I can make a call stack analysis or heap dump analysis because it can be related with the GC. So I have a chance to see that. Again, it's a normal basic application insights features. So I have a chance to see the application map in here. Not last, let's say that last 20 minutes. It will come in 5 minutes. So basically, we will deep dive into next session. For example, this one, this insights get method. No, not in here. One sample in here, and from the duration, I have a chance to see that the what's going inside my application within the application insight. So in the next session, I will tell you the memory analysis, and we will make some good application insights samples. So this is the basic troubleshooting of the JVM applications. First of all, what we have, the key takeaway is, first of all, if there's a CPU operation in here or CPU block, CPU, is CPU utilization too low, dump the first of all stack and make your analysis. If there's a high memory usage, then, or if you suspect about the memory leak, dump the memory. And if you have some HTTP clients or these analysis on your web page from within a portal, then use application insights for that. So I think I finished all my time talking too much. It's your turn, Mert.
So let's open our camps. So I have a question for you. You said that it is working as an agent, and you wrote that it's a Java agent and application insights jar file. So is there any difference between the .NET version and the Java version? Because in .NET, we are using a DLL file. I think it's directly integrated into our application. But in the Java side, is that agent can integrate in the application? Is there any missing features?
No. Yes, there are some missing features, but they're on the roadmap. But think as you add it as a DLL, but because of the language runtime in the Java, you set it from the Java agent, because Java agent is a parameter of a Java. So in the .NET side, you should add it in DLL to your project. That is the difference because of the language runtimes, because of the language provides. So you don't need to add, for example, DLL, or you don't need to drop a DLL to your application. You just set the Java agent to your Java application. So whole profilers, the Dynatrace or New Relic or other stuff, profiles the application as the same way that we are doing, because there's a parameter Java agent. So if you write your application, your profiling application in that override methods, then you have a chance to retrieve all information from the application.
Okay, great. So let's say we can do it next week.
Okay.
For the second part.
For the week, let's take it offline. Okay. Next week or 2 weeks later.
Okay. So thank you very much.
Welcome.
See you
Do you
soon.
have any question? Okay, I don't know. Okay, have a good day.
Bye. Okay, bye.